basic program debugging, creating a custom debug configuration, and attaching to a running process. Okay, we're on to section 6, debugging. Wow, can you believe how much we've covered already? Well, no guide to Eclipse and C++ would be complete without talking about debugging. Debugging on a large project is something that can take several times longer than the original creation of the code base. I am really passionate about having good debugging skills. Not only do you need them to debug your own code, but also to debug other people's code where you might not have the insight of why or how they chose to solve a particular problem programmatically. There really is no substitute to learning how to use a debugger, no substitute. You can only get so far with printf statements. Although I'm all for using printfs if the occasion demands it, but sometimes you need something more. A debugger like GDB is like opening the door into your code and seeing what happens while it is actually executing. It's awesome stuff. Regular readers of my website will know how much I love GDB, so I'm super happy to tell you that the Eclipse debugger now integrates GDB in a really nice way. Gone are the days when you had to set it all up yourself. Now, because debugging ncurses programs is a little bit more involved, I'm going to start by showing you how to use the debugger on the Hello World program that we created in lesson 2. You do still have that, right? If not, pop back and create it now. Right, I'll just close the Maze Run project and open the Hello project. Before we run the debugger, let's open up the hello.cpp file and adjust the program as follows. I'm going to add some extra lines of code here. So int x equals 10, int y equals plus x, and int z equals x plus y. See out value of, hold on, that should be z just there, z equals x plus y. Value of z is z. Hold on, oops. There we go. I've done this so we have some variables to look at in the debugger. Ignore the fact that we aren't going to search for or find a bug in this code. What I want to do is cover the use of the debug perspective. So from the menu, select Run Debug or just press F11. First up, you'll get this dialog that tells you Eclipse is changing perspectives. Remember that we opened the C++ perspective back in lesson 2? Well, this is going to take us into the debug perspective, which will rearrange the windows and menus for debugging. So click yes. You can check the box if you don't want to be reminded each time that we're changing perspectives. Eclipse does this big shift, and here we are. You can see the perspectives in the top right here, and you can still switch between them, C, C++, and debug without affecting anything. What's actually happened here is that Eclipse has run our program under GDB and then stopped execution at the top of the main function for us. You can see this in two ways. Firstly, there is an arrow in the source file that shows which line we are paused at. Secondly, on the debug view, which shows the threads that are running, we have just one thread here. You can see it's telling us we are in main at line 14. In fact, if you hover over the current location, you get a little pop-up that says debug current instruction pointer. We've still got our console output down at the bottom here. To the top right, we have several debug information windows, variables, breakpoints, registers. You can expand the general registers and see the values for each one on your processor, which is quite nice. and modules. Modules are the libraries that we're using. You can close this really. I would assume that standard libraries are far less likely to have a bug in than our code. Below that we have the outline view, which shows the structure of our code. I'm going to close that. And also the multi-core visualizer, which is a brand new feature to aid in debugging on multiple core processors. I'm not going to talk about that at all, so we can close that too. If you've used a debugger before, you're probably familiar with the idea of stepping through code. This concept basically allows us to execute one line at a time and see what happens to our program. The main menu area that you want to use is here. You can see resume, interrupt, terminate, step into, and step over. These work as you would imagine. Run tells the program to carry on executing. Interrupt stops execution. Terminate ends the program. Step into takes the debugger into the function on the current line, and step over ignores any calls and steps to the next line. If step into doesn't find a function, it will act as step over. Let's press step over now. You can see the arrow has moved down one line here. The debug window has updated our location to line 15, and execution is still paused. X is now highlighted in yellow in the variables window, and that means that it has been changed. Let's step over again, and you can see both X and Y have changed from this next statement and are now set to 11. You can terminate your program anytime you want by pressing terminate here, and you can see everything has stopped. Restart with run debug or F11 again. Okay, let's add a breakpoint. I'll make the breakpoint window visible so you can see it appear. You can insert a breakpoint really easily by just double clicking in the left hand side margin of the source code at the line you want to stop at. In the breakpoint view, you can see it has appeared by file and line number. You can make it active or silent by checking and unchecking the box. When unchecked, you maintain the breakpoint, but the debugger ignores it. Now, if we press resume or run, execution will run until it hits your breakpoint and then pause, and you can see your variables are all updated in the variables view. If we step over again onto the line that outputs the result to the screen, you can see that X and Y remain the same and Z has been updated to 22. Now, did you know that was going to be the output, or did you think it would be 21? It's an easy mistake to make, and another reason why it's so lovely to see it happening in a debugger. It's literally a window into program execution. Okay, so press resume again and the program will run to completion. You can see the output of the program in the console window at the bottom. We've only covered a handful of things here, but these are the fundamental building blocks of being able to debug your own programs. If you can run the debugger, set breakpoints, navigate through the code, and examine the variables, you're off to a great start. In fact, after you've learnt the basics, a lot of debugging skill really comes from honing your own understanding of how programs are seen by the computer. Let's close the debug perspective and take a quick look at the debugger settings. You won't usually have to change anything in here, as Eclipse's integration with GDB is much better than it used to be. However, it's good to know where to find these settings just in case. Right click on Project, Debug As, Debug Configurations. If you look under the Debugger tab, you can see that we're using GDB. If you want to use a different debugger, you can configure it all here. You can tell the debugger not to stop at main if you like. Sometimes, if you're using your own breakpoints and repeatedly debugging, it can be a bit annoying to keep having to resume after hitting main. You can also enable reverse debugging here, and you can specify the location of your GDB init file. If none of this is familiar to you, I've got lots of posts on my site about GDB. Just search for GDB or check out the list on my start page. You can find the link in the checklist. The Arguments tab is where you pass in arguments to your program if it requires them. Okay, so we can close that down. The last thing we're going to do here is set up debugging for the ncurses game. There isn't a lot of information out there on how to debug ncurses, and the techniques are applicable for other non-console programs that you may build and want to debug in the future. Let's close the Hello project as we're now finished with that. Then open the Maze Run project. Open Run Debug Configurations. Select C++ attached to application and click the button at the top here to add a new launcher. It has a default name, which is fine. You can edit the debugger tab if you want to enable reverse debugging or change the GDB init file. I'll just leave it all as it is. Under the Common tab, check Display in Favorites menu. This just makes it easier to access from Eclipse. Leave everything else as is and hit Apply and Close. Now run the external tool that we set up in Lesson 3 to run our Maze Run game in the Genome console. Then select the Debug drop-down here and click the Maze Run debug configuration we just created. Select the process in this list by typing in the first few letters, M-A-Z, there it is. Then Eclipse will switch to the debug perspective and halt the program. Now it looks a bit odd to start because you have this message about no source for read, no cancel. But if you look in the threads list and scroll down the stack, you can see that the debugger has interrupted the program at main.cpp 45, line 45, which actually takes you to the run method in the maze class. There it's waiting for this get character method. So the message about the missing source is actually about library code that we don't need to see anyway. If we press resume, the program is still waiting for our input, but it's now running. So if we switch to the terminal, you can move the human around as usual. The program is now running under the debugger, so if it crashes, you should get a stack trace of where the crash occurred. Go back to Eclipse and let's scroll down here to the move method in the Ghost class. Press F3, the shortcut to take you to the declaration, and in the move method, let's press F3 again on chase human. That takes us to the declaration, and at the top of this method we'll add a breakpoint. Now back in the game, when we move our human, the debugger hits the breakpoint and takes us back to Eclipse and stops execution at the top of the chase human method. In fact, if we press resume now, it stops again, and that is the second ghost who's also chasing us at this point. So press resume again, and the program is now waiting for our move, and when we move, it stops again. Okay, let's disable that breakpoint by unticking the box. Now we can move around, and oops, the ghost got me. I'll press Q for quit, and in the debugger you can see the process has terminated. Now you might ask, what if you want to debug the program during startup? Attaching to a running process means you can't get the debugger on what's happening at the beginning. This is a good question. There doesn't seem to be any way in Eclipse to successfully access the application at startup via the debugger. Ncurses doesn't work correctly in the default Eclipse console, which is why we created the external tool to launch the game, because it doesn't handle keyboard input, but there's no way to start the debugger via the external tool that we created to run the game. There is a way, although it's not via Eclipse. There is a tutorial on my site which I've linked to in the checklist that explains how to debug any console app, not just an Ncurses one, on the command line with GDB and GDB server. This will help you if you need to debug startup code and attaching to a process is too late for you to catch a particular bug. Right, one more quick thing before we finish up with this lesson. Sometimes you just want to talk to GDB without the GUI getting in the way. Although Eclipse is actually very good now at passing through commands, if you want to tell GDB to do something directly, you can access it via what's known as the GDB console. Let's just run the debugger again. So I'll start the program, then run the debug configuration, and attach to the process. Right, when the debugger is up and running, select the console choice button here, and you can see two that relate to our debug configuration: GDB traces and GDB. GDB traces is all the interaction between Eclipse and GDB. We don't need that. The GDB option is the one that we want, and that is a command line interface into GDB itself. So for example, if I type info threads here, GDB returns the information on the single thread that is running. It's a really handy way to bypass the GUI if GDB isn't doing what you expect, or you can't find an option for a particular GDB command in the Eclipse interface. Great. We're done on debugging, almost. We've covered using the default debugger and how to set up a custom debug configuration that attaches to a running process. In the next lesson, we'll look at debugging using the native genome console rather than the built-in Eclipse one, and then in the final lesson, we'll examine the game code in greater detail.